going to take a look at a second proof and a way to determine whether something is in fact, or whether that a power of 0 is in fact 1. This one's going to be a little bit more theoretical. It's going to involve a little more algebra. This is in fact a deductive proof that goes through this. We're going to look at this following expression here. So this expression is 3 squared times 3 to the power of 4. Now, if we write this out in a little bit of a stretched out form here, 3 squared is 3 times 3. And then we're going to multiply, and I'm just going to kind of move this off to the side a little bit here. Put another x there. Okay, so if we kind of think of this times 3 times 3 times 3, okay, this is what this expression is telling us here. It's 3 times 3, and then we're multiplying 3 times 3 times 3 times 3. If we think of this as a large expression, okay, as a large expression altogether, really we're just multiplying 3 together 6 times. Okay, so we're multiplying 3 together 6 times. So we could rewrite this, and we're going to go through this later on in the semester, but we could rewrite this as 3 to the power of 6. Okay, so there are 6 3's here. There are 2 and 4, so we add it together, we get 6. So you'll notice that the exponents become added together and give us 6. And in fact, that's the number of times we're multiplying 3 together. Now, if we try it with a generic number, so again, we're going to use algebra in this case, we're going to use a variable. If we do x squared times x to the 4th, this gives us, as we showed here, it's going to be x times x, and then we're going to multiply by x times x times x times x, okay? Which in fact is going to give us x to the power of 6. Okay? Again, this x to the power of 6, okay? Just like we did here. So instead of there being a 3, we just replace that with x. So anytime we have two powers which are have the same base multiplied together, the answer is going to be the same as the base with the exponents added together. Therefore, we have 2 and 4, we add them together, we get 6. So if we have, and again, this is if the bases are the same. We can't do it if we have different bases. They have to have the same base, right? Like 3 and 3 are the same, x and x are the same, so it works out okay. Now, let's do an example where we deal with an exponent of 0. So 4 to the power 3 times 4 to the power of 0. And now using the same philosophy or the same idea that we came up with earlier, 4 to the power 3 is 4 times 4 times 4. And then we're going to multiply by something. If we, again, we're just going to assume that we don't know what 4 to the power 0 is. But look at this, we're going to use the same pattern. Let's add the exponents together. 4 plus 0 is 4 to the power of 3. So this answer here would be 4 to the power of 3, right? Because we have 3 and 0, which adds up to 3. So that means that we should have 3 4s multiplied together as our answer, and we already have that, but we have something that we need to multiply there. Okay? Now, the only value that we can use that when we multiply by it doesn't change our answer is 1. Okay, that's the only thing that will not change our answer. If we multiply by 0, gives us an answer of 0. Okay, so it won't give us an answer of 4 to the power 3, it gives us an answer of 0. So therefore, this right here, and I'm just going to draw out a little bit of an arrow here, this right here was going to fill up this space. The only possible explanation that it could be is a 1. That's the only possible explanation. It can't be anything else because anything else is going to change the final answer. But the final answer needs to be the same as the original answer. And that's using our understanding that when we multiply the same base together with exponents, we can add the exponents together to come up with our final answer. This is our proof that we're going through here. So therefore, 4 to the power of 0 has to be 1. Okay, which we did earlier. Now here's where we get to the deductive part where we actually use variables for it. Okay, so let's just take a look at the generic proof. Here we have x to the power 3 and x to the power of 0. Now using the same philosophy that we went through earlier, we know that 3 plus 0 is going to equal to our final one. So this would be x to the power of 3. Okay, it would be x to the power of 3. Now let's show that without, we're going to try this here. X, I can't believe we don't have a dot here. Maybe trying to find, no, I guess I'm just going to have to use the multiply sign. So then x to the power of 0 is 1. And again, this is going to equal x to, x to the power of 3. Too many x's there. Okay, so therefore, we know that this is in fact the case. We know that the this has to equal x to the power of 3. We already have 3 x's, so our remainder there has to be 1. So this has to be 1. And this is going to be the rest of our x's. Therefore, based on this proof, any number with an exponent 0 must equal 1. Okay. Now, your assignment today is dealing with proofs of 0. And yes, the answers are usually very simple. It's either 1 or -1, depending on if we have, let's say, brackets, something like this. This is going to give us an answer of 1. And if we have -6 to the power of 0, it's going to give us an answer of -1. So remember that those brackets are very important. It changes our final answer. These are really the two answers that we're going to get no matter what. Okay, so anytime we see to the power of 0, we're going to get 1. Your assignment today is going to be showing it with proofs. Okay, so showing it with proofs is going to be part of your assignment.